I'm coming up to publishing 30 courses on Pluralsight, and although I've done a bunch of stuff on YouTube lately, I haven't shown you any clips of my Pluralsight courses, so I'm going to put that right now. And I'll be starting with a clip from my popular course, Managing Apps on Kubernetes with Istio. So we're going to see about 10 minutes of the full course. We're going to see a demo doing Canary deployments with Istio, and then a walkthrough of some of the concepts we've looked at. And at the end, there'll be a link to the full course. And if you don't have a Pluralsight subscription, that's cool, because you can get a free trial and watch the whole thing. Okay, so here we go. This is how you do Canary deployments with Istio. In this demo, we're going to use Istio to do a Canary deployment. We'll start by having most of the traffic weighted to version 1 of our application, but we can gradually shift that traffic over to version 2. And then we'll look at how you get over one of the problems of Canary deployments, which is making sure that users get the same experience during your rollout by doing a Canary deployment together with sticky sessions. Okay, so this demo follows on from the previous one, so I've still got everything running. And if I check my pods here, from the product page, I've got my V1 product page and my V2 product page. They're still up and running. And I've still got my gateway listing for all traffic and my virtual service that's listing for bookinfo.local. For my Canary deployment, it's just a change to the virtual service again. So here's my YAML file. I'm changing the bookinfo virtual service, which is the one that binds to the gateway and sets the rules for the host bookinfo.local. There's only one route defined in here, but there are two destinations. So the first destination sends 70% of incoming traffic to the V1 subset, and the second destination sends 30% of traffic to the V2 subset. Now I've still got my test.bookinfo.local virtual service set up, which is sending all traffic to V2. So I can always use my test site to look at V2, and I'm going to gradually do a rollout of my live deployment to go from V1 to V2. Okay, so I'm going to apply this, and it just changes my one virtual service. I can see that my original virtual service for the test site, that's still up and running. So if I browse to test.bookinfo.local, that's always going to go to my subset V2. But if I browse to bookinfo.local, now I'm going to hit my Canary deployment. And Istio is going to shift the traffic 70% in favor of version 1 and 30% in favor of version 2. So let's see how that looks. So I'm on my bookinfo.local. If I refresh, most of my responses are the version 1 response, but every now and then I will see my version 2 coming up. So the weighting between version 1 and version 2, I've got down as 70-30. It's not going to be exact with a single user hitting refresh every now and then. The larger the load you have, the closer you'll get to your specified weighting. So at the moment, most users of my site are going to be getting version 1, and occasionally a user is going to get version 2 and be treated to the new design. And then the Canary deployment is just a case of changing the weightings. And you can decide how long to take for the rollout and what the traffic weighting needs to be. So maybe you'll do this over a series of hours or a series of days or even weeks, depending on the level of confidence you need to get with each update. So if I want to increase the amount of traffic that's going to version 2, I could do a 55-45 split. And the only thing that's changing in these YAML files are the numbers in the weighting. And then when V2 is going to take the majority of the rollout, I can do a 25-75 split. And then finally, I can do a 0-100 split and send everything to my version 2. So you see how a Canary rollout works. We've effectively got two live versions and we're weighting the traffic between them. But the problem there is if I'm a user of this site, sometimes I'll see V1 and sometimes I'll see V2. And depending on where we are in the rollout, I might see V2 more often or I might see V1 more often. And that's not a very good user experience because each time I use the site, I might see something completely different. So a more advanced deployment strategy is to join my Canary deployment along with some specific request matching. So if I open the networking tab here, and if I refresh until I see version 2. So in version 2 of my product page, as well as having the visual makeover, there's a cookie that comes in the response saying that the product page is V2. And I can use that to improve the user experience during the rollout. So what I want to happen is the Canary rollout is going to be random, but if I see version 2, then from then on, I should always see version 2. So the rollout might be happening globally, but everyone who's seen version 2 will continue to use version 2. So I won't get this weird experience where I saw version 2 and then next time I got back to version 1. And Istio can do that request matching based on that cookie. So for the more advanced Canary deployment, I'm going to combine the request matching that we saw right at the beginning when I was getting the username with my Canary deployment. So inside here, again, it's just a change to the virtual service. So this is my bookinfo.local. And in the request configuration, I've got a match here that's looking for that cookie. So if the request comes in from the user, if they've already seen product page V2, then they will have that cookie that comes in the request. And Istio will find that cookie and send that user to V2. So anyone who's seen V2 will continue to see V2 because they'll fall into this match route. And for anybody else, so if I haven't seen v2, I don't have a cookie, then I go into the ordinary Canary waiting rules. So in this case, it's 70/30. Most of the time I use the app, I'll see version 1. Eventually I'll see version 2. And from then on, every time I use the app, the cookie goes into my request, Istio picks that up, and I'll continue to see version 2. So it's still a Canary deployment where I can configure the waiting rules, but I get a better user experience in here. The deployment is the same. So let's shrink this down. It's just a kubectl apply, same as always. It's just a change to the virtual service. If I refresh here, because I've already seen v2, I'll continue to see v2. The cookie is tied to the domain name. So every time I make a request to bookinfo.local, the browser is sending my cookie. So I'm matching the request from Istio and I'm getting v2. But if I want to test the Canary is still working, I can disable cookies from my browser. So with Firefox, I'm going to do that by opening the options. And if I search for cookies, then down here in the site data, I can manage the permissions for each domain name. If I put bookinfo.local in here, I can block cookies. So now my website won't send any cookies now, so there'll be nothing for Istio to find. So now when I refresh, I'm going to fall into the default route. So now I'm going to get the Canary rollout. Most of the time I'll get v1, sometimes I'll get v2. And because I'm not sending cookies anymore, I can test the fact that the rollout's working as expected. And if I clear those options down again, then I'll go back to sending the cookies. And I'll continue to see v2 every time I use the application. So that's Canary rollouts, shifting the weight between different subsets, but also using a cookie to give users a better experience. So in that demo, we saw how to do Canary deployments, to have two versions of our application live, and to use Istio to shift the weighting of the traffic between those two versions. And again, we're configuring that with the same type of Istio resources. So that's all done in the virtual service, where for a particular route, I can have multiple destinations. So on the left-hand side here, I've got a 70/30 split. The majority of traffic is going to v1, and 30% of traffic will go to v2. And on the right-hand side there, this is way down in my deployment cycle, where only 5% of traffic is going to v1, and the other 95% is going to v2. Now, we also saw in that demo that during the Canary rollout, users can have a kind of strange experience where sometimes they see v1, sometimes they see v2 because the weightings are random. And we saw how to fix that using a cookie. So there's some application work here to make sure that you set the cookie, but as long as the cookie's there, you can do a staged rollout with a kind of sticky session experience. So as soon as users have seen v2, the request that comes in will have that cookie, product page equals v2. That matches this first rule in my virtual service definition. So those users will always get sent to subset v2. Any other users that don't have that match, they'll fall into the default route, which in this example has my 70/30 split. So I get a Canary deployment, I can do a staged rollout, I can gain confidence in my new version, but I can still support a good user experience. So the last thing we're going to cover in this module is a different type of scenario that uses the same features of Istio. But this time we're going to use those features to increase the reliability of our application. So in this example, I've got a new version of my details component and I'm running that at scale. So in Kubernetes, I'll have two replicas, two pods running identical software, and Istio is going to load balance requests between those two pods. Now, if the application starts to fail in one of those pods, by default, Istio is going to keep sending traffic to it. And that's a problem for two reasons. Firstly, because this instance may stay unhealthy now, but Istio is going to keep sending traffic to it, so it will keep getting errors. And the second part of this problem is if I've configured Istio to automatically retry when it gets errors, and we saw how to do that in the module called Introducing Istio, then what I'm going to end up doing is sending even more traffic to this failing component, and that can amplify the problem. And Istio lets us fix this using a circuit breaker pattern. And what the circuit breaker does is it monitors the behavior of all of the instances that are in that load balance group. And if one of them starts to fail, it takes it out of the group. So it doesn't send traffic to it anymore. And you can configure how long to watch for errors, how many errors trip the circuit breaker, and how long to keep failures out of the group. So if that instance has failed temporarily and a period of calm allows it to reset, then the circuit breaker pattern means when it comes back into the load balance pool, it could be working correctly, and this will keep your app running even during transient failures. Now, even though this is a completely different type of traffic management scenario, it's still traffic management, so you still use virtual services and destination rules inside Istio to configure this. This is internal communication between my product page service and my details service. So there's no gateway involved because the traffic's being routed through my Istio proxies, so I just need to set up my virtual service and my destination rule. And this is how that looks. So I've got one pod running version 1 of my details component, and I've deployed a new version, version 2, which is running at scale across 3 pods. Now, if I want to send all traffic to version 2 of my component, I can have a virtual service where the host is details, configured to use the subset v2, which is using that label to send traffic among those 3 pods. Now, with this configuration, client requests get load balanced between those 3 pods. So Istio will share the load between all those pods. And if the application in one of those pods starts to fail, Istio is going to carry on sending traffic to it because it's still part of the load balance group. Now, to apply the circuit breaker, I add a traffic policy to my destination rule, and the traffic policy sets up outlier detection. Now, the outlier detection is just telling Istio to watch all the endpoints in the load balance group and make sure they're still behaving themselves. So in this case, the configuration is saying that if any one of those endpoints has 2 consecutive errors within a 1-minute period, then it's going to get ejected from the load balance group for 5 minutes. So if this pod at the top here has 2 errors in a row, then it gets taken out of the group and it won't receive any more traffic for the next 5 minutes. And that's the circuit breaker pattern. So we're telling Istio to monitor all the endpoints in the load balance group to find any outliers that start behaving badly, and will eject them from the group for a certain period of time. After that, they come back into the group and they'll start receiving traffic, but they're still being monitored. So if they fail again, they'll be ejected again. And we'll see how that looks in the demo coming next. Okay, so I hope you found that useful. There's an awful lot of stuff you can do with Istio, and I cover it all in this course. So if you're interested in watching the next demo and in learning what you can do with Istio around security and traffic management and observability, then head to this short link and check out the full course on Pluralsight, managing apps on Kubernetes with Istio. If you don't have a Pluralsight subscription, you can get a free trial and watch the whole course, and you can check out my other courses too, and there'll be some more clips of those coming up soon, so be sure to subscribe to my YouTube channel or check me out on Twitter.